Hello, hi everyone. Welcome back to Chiplets in VLSI Part 2. So previous week we discussed about Part 1 in Chiplets of VLSI. So we are presenting it from Radiant Semiconductor, so which is a service company founded in 2018 with headquarters in Bangalore and branches in Hyderabad and USA. So about the presenter, so Casey has 18 plus years of experience in VLSI and currently working as Senior Director at Radiant Semiconductors, taking care of end-to-end product development. So let's recap some of the things which we discussed with respect to chiplets in last week. So introduction to chiplets. So as we know, chiplets are small modular chips that can be combined to form a complete system on chip. They are designed to be used in a chiplet-based architecture in which multiple chiplets are connected together to create a single complex integrated circuit, right? So chiplet-based architectures offer several benefits over traditional monolithic SoCs, including improved performance, reduced power consumption, and increased design flexibility. So chiplet technology is relatively new and is being actively developed by a number of companies in the semiconductor industry, right? Now, chiplet is a new type of chip that is paving the way of designing complex SoCs. So, chiplet can be considered as a high-tech version of Lego building blocks. Right, a complex function is decomposed into small module, then chiplets that can perform that single specific function very effectively. Hence, an integrated system using chiplets can consist of data storage, signal processing, computing, and data flow management is called as chiplet. So, chiplet is part of packaging architecture and it can be defined as a physical piece of silicon that encapsulates IP, which is nothing but intellectual property, subsystem with other chiplets by using package level integration approach. We can say that chiplet technology integrates multiple electrical functions in a single package or a system, right? Now let's see more about chiplets. Okay, introduction to chiplets only. Let's recap. As part of part one, utilizing chiplet technology, engineers can design complex chips rapidly and cost effectively by essentially assembling different types of third-party IPs into a single chip or package. These third-party IPs can be I/O drivers, memory ICs, and processor cores. Right. The idea of chiplets originated from the project of DARPA chips, right? As the most advanced SoCs are not always acceptable for small-scale applications. So for improving the overall system flexibility, the chip plan seeks to create a new paradigm for IP reuse, which is chiplet. While computer technology is still largely dominated by traditional chiplets in most electronic devices today, it seems clear that this trend will change as time goes on. Many experts believe that specialized chiplets will become a common feature in consumer devices as these advanced technologies unfold. There are many reliable and cheaper technologies available for designing the chiplets. Moore's law is a predictable mode by Gordon Moore, co-founder of Intel, in 1965, that the number of transistors on a microchip would double approximately every 2 years, right? So leading to exponential increase in computing power and decreases in cost. So chiplet technology can be seen as a way to extend Moore's law and continue the trend of improving performance and reducing costs in the semiconductor industry, right? So let's go to CPU, right? Which is made up of chiplet. So one way in which chiplet technology can help extend Moore's law is by allowing for the creation of more complex and powerful SoCs without having to fit all of the necessary components onto a single monolithic chip. By breaking a complex SoC into a smaller modular chiplets and connecting them together, it becomes possible to continue scaling up the number of transistors and other components without hitting the physical limits of a single chip. This can help keep pace with the performance improvements and cost reductions predicted by Moore's law. Nowadays, the heterogeneous chiplet integration market is growing more rapidly. Different microprocessors like AMD's EPIs and Intel's Lakefield are high in volume manufacturing with the chiplet designs and heterogeneous integration packaging technology. This is a brief about chiplets introduction, which we discussed last week. Now let's look at some of the history of chiplets. Let's recap the history of chiplets. Okay, the concept of chiplets has been around for several decades, right? But it has gained more attention in recent years as a way to address the challenges of scaling down traditional monolithic ICs. With the continued advancement of Moore's law, the size and complexity of monolithic ICs has increased significantly, leading to higher costs and more difficulty in manufacturing. So chiplets-based design offers a potential solution to these challenges by allowing companies to use smaller, more specialized chiplets that can be easily combined and assembled into a complete system. The term chiplet is relatively new and has only been used for about 5 years or so. Right? It was originally coined by researchers and scientists at the University of Michigan as they began investigating ways to improve computer chips, design efficiency, and functionality. The term is a combination of the word chip and the word petite, which can be translated to mean small. Right? So a chiplet is a very small computer chip used in high-tech devices to perform more complex tasks than traditional CPU chips. It has developed rapidly over the last few years, and many experts believe that it will begin to replace traditional chiplets in consumer devices due to its enhanced functionality. So in May 2007, DAPRA, right, started its first COSMOS compound semiconductor material on silicon for heterogeneous chiplets. So DARPA started chips whose purpose was to make modular computers out of chiplets. It also addresses different integration standards, IP blocks, and the design tools available. Right? This is a brief about the chiplet history. Now let's look at the market forecast. Let's recap the market forecast which we covered in the part 1 of chiplets presentation last week. So according to the information provided, right, the chiplets market is expected to experience significant growth in the coming years. In 2025, the market is forecasted to reach a value of $5.7 billion according to a report published by Markets and Markets. This represents a compound annual growth rate of 18.9% from 2020 to 2025. In 2031, the chiplets market is expected to reach a value of $47.2 billion, according to a report published by Transparency Market Research. This represents a CAGR of 23.9% from 2021 to 2031. The forecast takes into account the increasing demand for high-performance computing and data analytics, as well as the growing trend towards modularity and customization in electronics design. These figures suggest that the chiplets market is poised for promising growth in the coming years. Chiplets are small modular chips that can be combined to form a larger, more complex system on a chip. They offer a number of benefits over traditional monolithic chips, including improved performance, cost savings, and design flexibility. These factors, along with the increasing demand for high performance computing and data analytics, are likely to drive the growth of chiplet markets in the coming years. Right? Now let's see benefits of chiplets. Right? Chiplets offer several important benefits over traditional monolithic processor designs. They can be customized and upgraded rapidly and easily, and therefore reducing development time and costs. Perhaps most importantly, chiplets improve performance by using specialized processing elements optimized for particular tasks. Right? For example, if you need high processing power for AI applications in your device, you could replace the traditional CPU with a chiplet designed specifically for AI tasks. Right? In addition to these performance benefits, chiplets make it possible to reduce processor size and power requirements. By consolidating multiple individual functions into a single chip, right, they eliminate the need for much of the wiring, cooling infrastructure, and other components required by conventional chips. Right? Right? So this is one of the latest trends in the SoC. Right? Now this lowers manufacturing costs and allows for smaller device designs ideal for mobile devices like smartphones or AR or VR headsets. The flexibility offered by chiplets also provides important design and development benefits because they can be customized and upgraded easily. Chiplets allow manufacturers to quickly adapt to changing market conditions or new technological developments. They also simplify the production process by reducing the steps required to design and manufacture customized SoCs. Right? Now, let's see what other advantages are there. Right? Chiplet technology can help improve yield and reduce costs by allowing manufacturers to use smaller, more specialized chiplets rather than a single monolithic chip for certain tasks. This can help improve yield because it reduces the complexity of the chip manufacturing process, which can reduce the number of defects that occur and increase the overall yield of unusable chips. Additionally, because chiplets can be designed and manufactured separately, it can be easier to optimize the manufacturing process for each specific chiplets, which can further improve yield. Another way in which chiplets can help reduce costs is by allowing manufacturers to use a mix and match approach to creating SOCs. Rather than designing and manufacturing a new chip from scratch for each new product, manufacturers can instead use a combination of pre-existing chiplets to create the desired SOC, which can be easier and more cost-effective. This can be particularly useful for companies that need to bring products to market quickly and need to be able to make rapid changes to their SOCs to meet changing market demands. Right? Now let's see some of the challenges. We discussed about the benefits. Now let's look at some of the challenges what we are facing in the chiplets design. Right? We are just recapping the part 1 which we discussed last week. The following changes are encountered by the chiplets technology. The first and the foremost challenge is to ensure the low cost and high reliability of chiplet mode, and it is based on the advanced packaging technology. So packaging technology is the focus of attention for chiplet. Its significance can also be observed from the positive shift of TSMC to packaging and development of other packaging technologies like Info and Co-WOS. The second challenge is to maintain good quality of product with an economical product rate. Even though chiplet is a certified product, but still there is a yield problem. The whole system of chiplet becomes more costly if some problem is found in one of the chiplet silicon chips in SIP. Right? So the graph, right, depicts the percentage yield with respect to chip area. Another permanent challenge is testing coverage. Since multiple chiplets are embedded together, each chiplet can be connected to limited number of pins. Some of the chiplets become inaccessible outside the pins, which results problem in chip testing. Right? So now let's look at the big players in chiplets. Right? Let's come to the part 2. We closed the recap of part 1. Now let's go to the part 2. Let's look at some of the big players in the chiplets industry. Here are the 10 companies that are actively working on chiplet technology. Right? Intel is one of the leading companies in the semiconductor industry and is actively researching and developing chiplet technology. The company has announced plans to use chiplet-based architecture in its future processors. AMD is another major player in the semiconductor industry and is also actively researching and developing chiplet technology. The company has already released processors that use chiplet-based architectures. IBM is a leading provider of advanced semiconductor technologies and is actively working on chiplet technology. The company has developed a chiplet-based architecture for its power processors and is also researching the use of chiplets in other applications. TSMC is a major contract semiconductor manufacturer and is actively researching and developing chiplet technology. The company has announced plans to use chiplet-based architectures in its future processors. Samsung is a major player in the semiconductor industry and is actively researching and developing chiplet technology. The company has already released processors that used chiplet-based architectures. GlobalFoundries is again a major contract semiconductor manufacturer and is actively researching and developing chiplet technology. The company has announced plans to use chiplet-based architecture in its future processors. SK Hynix is another major provider of memory and storage solutions and is also actively researching and developing chiplet technology. Micron is a leading provider of memory and storage solutions and is actively researching and developing chiplet technology. Qualcomm is a major player in the mobile chip market and is actively researching and developing chiplet technology. The company has announced plans to use chiplet-based architectures in its future processors. Huawei is a leading provider of telecommunications equipment and is also actively researching and developing chiplet technology. The company has announced plans to use chiplet-based architectures in its future processors. Right? Now, while many challenges come with chiplets, right? So, especially in the context of commercial applications and scalability, they offer a promising solution to some of the today's most pressing chip design issues. With continued development and innovation, we can expect to see more widespread use of chiplets soon. With the chiplet technology gaining momentum, it's only natural that many big players in the industry are starting to get involved. Global Foundries and Samsung are two major companies at the forefront of this trend, each working on their own solutions to the chiplets challenge. Intel, AMD, Qualcomm, ARM, TSMC, and Samsung are working together for defining new standards for chiplet-based CPUs. There is a sizable group for UCIe, Universal Chiplet Interconnect Express, promoters which includes AMD, ARM, Intel, and Qualcomm, chip fabs, TSMC, and Samsung, right? Chip packaging firm, advanced semiconductor engineering, and cloud computing providers like Google, Microsoft, and Meta, right? Now let's see the difference between chiplets and SOCs. This is an interesting topic. Compared to SOC, a chiplet is a smaller scale circuit manufactured separately from the rest of the device. On the other hand, SOC integrates all of its components onto a single silicon. Individual chiplets are connected using 3D stacking technology. This allows for each module to be optimized individually and means that the chip can be scaled without affecting performance. For example, chiplets can be made more power efficient than those SOC and still maintain the same level of performance. Because of this customization and modularity, chiplet designs are also easier to manufacture, making them a good choice for devices that do not require high performance circuitry. Although some drawbacks of chiplet designs exist, they are generally considered the most efficient alternative to SOC solutions. While there is a contrast in heterogeneous chiplet integration, these chiplets redesign into smaller chiplets and then packaging technology is used for integrating dissimilar chiplets that perform different functions. So that's where we have two types of heterogeneous chiplets integration. One is chip split and integration, chip partition and integration. Now let's look at into these two types. Chip split and integration. In this approach, SOC logic is split into multiple logics like logic 1 and logic 2, logic 3. They are stacked together either by COW, chip on wafer, or WOW, wafer on wafer, as depicted in the following figure. The front-end integration yield smaller package area as well as better electrical performance. Right? Chip partition and integration. This scheme is shown in the following figure. It can be observed that SOCs such as the logic and IOs are partitioned into functions. Logic and IO, they are then integrated using front-end COW or WOW method. Logic and IO chiplets are then assembled by utilizing cutting-edge packaging techniques on the same substrate for a single package. While there are many advantages to choosing a chiplet design over a SOC, there are also some drawbacks. For example, chiplets may be difficult to integrate and create a more complex manufacturing process than a SOC. Right? Moreover, the use of 3D stacking technology can introduce reliability issues when connecting modules together. Additionally, if one module fails, it may affect the functionality of the rest of the device, right? So these are the other challenges which we have to deal with. Overall, chiplet designs are generally considered more efficient than SOCs for modules that don't require high performance circuitry but demand customization. Although there are some drawbacks to this design choice, they are largely overweighted by its many benefits, right? As such, it may soon become the preferred choice for many types of devices, right? Now let's look at the chiplet standardization, right? So chiplet standardization efforts have been developed to help address issues related to the performance of these connections. These include improved thermal management, low power consumption, and reduced latency. They can also help to improve the efficiency of chip-to-chip communication and integration by increasing the amount of data traffic that flows through these connections. Chiplet standardization efforts are ongoing and there are currently a number of different standards in use for interfacing between chips, which is of the greater challenge. For example, Catchy Coherent Interconnect for accelerators (CCIX) is supposed to be a coming standard for SOC's chiplets. Multiple chips are contained within the same chip package, which together acts as a large single chip. To allow end users to easily mix and match chiplet components, the UCIe 1.0 specification offers a complete standardized die-to-die interconnect with physical layer, protocol stack, software model, and compliance testing. The following table shows the characteristics and key metrics of UCIe 1.0. UCIe standards cover the physical and prototype layers of chiplets design. Also, these standards define how chiplets should be connected together for communicating with each other. Two different performance levels for UCIe version 1.0 are defined for accommodating different package options, standard and advanced. In standard package scheme, 16 data lanes with 25 mm of space between the chiplets is defined, while in advanced packaging, 64 data lanes and 2 mm of space is allowed. The UCIe 1.0 standards are basically defined for 2D and 2.5D chip packaging only, but not 3D direct die-to-die technologies like the forthcoming Forest Direct. The standard will need to be updated as 3D chip packaging becomes available in order to take into account the additional features and even higher densities that will be possible. Right? So let's look at some of the future of chiplets. It's difficult to predict the exact future of chiplet technology as it will depend on number of factors including technological advancements, market demand, and the strategies of individual companies. However, chiplet technology has the potential to revolutionize the way processors and other electronic components are designed and manufactured. By allowing companies to mix and match different chiplets to create customized products, chiplet technology could lead to more efficient and cost-effective manufacturing processes. It could also allow for the creation of more specialized and customized products, as companies can select the specific chiplets that best meet their performance and power requirements. Overall, it seems likely that chiplet technology will continue to be an important area of innovation in the electronics industry in the years to come. Right? Now let's see some of the chiplet applications. Right? So chiplet technology can be used in a wide range of applications, including in processors, memory modules, and other types of electronic components. Here are a few examples of chiplet applications. Processors. One of the most common applications of chiplet technology is in the processors for computers, smartphones, and other electronic devices. By using chiplets, companies can create processors that are customized for specific performance and power requirements, and that can be more easily scaled up or down depending on the needs of the device. Memory modules. Chiplet technology can also be used in the design of memory modules such as DRAM or flash memory. By using chiplets, manufacturers can create memory modules that are more scalable and that can be customized to meet the specific needs of different devices. Networking equipment. Chiplet technology can be used in the design of networking equipment such as routers and switches. By using chiplets, companies can create networking equipment that is more flexible and that can be customized to meet the needs of different types of networks. Right? Now, these are just a few examples of the types of applications where chiplet technology could be used. It is likely that chiplet technology will be used in a wide range of other applications as well, as the technology continues to evolve and be adopted by more companies. One example of a Qualcomm chip that uses chiplet technology is the Snapdragon 888 processor. This processor is used in a number of high-end smartphones and is designed to deliver fast performance and low power consumption. The Snapdragon 888 is built using multiple chiplets, each containing a group of cores and other components. The chiplets are connected using Qualcomm system-on-chip technology, which allows for high-speed communication between the different chiplets and other components within the processor. The Snapdragon 888 is just one example of a Qualcomm chip that uses chiplet technology. The company has a number of other products that use the approach as well. There are several other companies besides Intel, AMD, and Qualcomm that are using chiplet technology in the market today. Right? This is just one example, chiplet-based system-on-chip for edge artificial intelligence. As you can see here, we have flash memory, field programmable gate array, There are two field programmable gate arrays. Microcontroller is there. 3-axis accelerator is there. 3-axis magnetic sensor is there. All these combinedly, it is system-on-chip. Okay, and this is a pure chiplet technology. Now let's go to the summary. So chiplet technology is a modular design approach that involves creating small self-contained chips or chiplets that can be combined to create a larger system. Each chiplet is designed to perform a specific function, and by combining different chiplets, companies can create custom solutions that are tailored to their specific needs. Chiplets technology has the potential to revolutionize the way electronic components are designed and manufactured. as it allows for more efficient and cost-effective production processes and enables the creation of more specialized and customized products. There are several key benefits to chiplet technology. First, it allows for more flexible and scalable designs. By using chiplets, companies can mix and match different components to create solutions that are tailored to their specific performance and power requirements. This can lead to more efficient and cost-effective manufacturing processes, as it allows companies to create products that are optimized for their specific needs. Second, chiplet technology can help to improve the performance of electronic devices. By using chiplets, companies can create solutions that are optimized for specific tasks, leading to faster and more efficient performance. Additionally, chiplet technology can help to reduce power consumption as it allows for more efficient use of resources. Finally, chiplet technology has the potential to accelerate innovation in the electronics industry. Right, by enabling the creation of more specialized and customized products, chiplet technology could lead to development of new and innovative technologies. Right. So I hope we all learned more about the chiplets. What are its advantages, challenges, what type of chiplets are there, how the market trend is, which companies are using chiplets, right, and how we are using Qualcomm Snapdragon, which is one of the chiplet product in all our smartphones, right. So hope the information was in it was useful and interesting. So we'll all catch up again next week with another interesting topic. All right. Thank you so much.